Hey everyone, and welcome to Dr. Abu RTN Academy channel. Today we are going to discuss part 1 of the distribution of random variable topic in the biostatistics subjects. Usually we need some numerical data like the height and what is the height of the first individual, second individual, third individual, and so on. The number of flowers in this garden, the number of diseases in this country, the blood pressure for individuals or for sample of people. So these numerical data are necessary for mathematical description of the probability. Okay. Within this, I have variable like the blood pressure, the hair color, the height, the weight, the mass, the weight, the length, the number of travels. So these called variables. Okay. The variable assigned to a random event. So if I came to a random event, like throwing a dice, okay, or a coin, so this is a random event. So the variable assigned here is called random variable. So random variables means it is a variable assigned to a random event. So the event is not biased, it is random event, and I'm taking some readings or some outcomes or some outputs from this events, so it's called random variable. So random variable is a variable but related to random event, not biased event. If I can see here in this sample which we have here, okay, we have number of individuals, and this is, for example, this one of the variable, okay, the height of the man. Okay, so here this is a man. Okay, so I have here two variables. The first variable, that whether he is a man or is a girl or lady, okay, male or female. Okay, so the first one is male or female, and the second variable is the height itself. So male and the female, I can count how many females here, okay, and how many males, I can count them. So it's called random variable because it's random. I can pick them randomly from the sample or from the population. So it's called random variable. Okay, and the second thing, the height. The height is randomly taken also, so they are called random variable. Okay, so for male and female, I have only limited options because I don't have any other gender character officially announced. So I have male and female, so they are limited. Okay, I don't have other choices. Okay, so it's called discrete data, discrete variable. Discrete means I have limited option, 2 options, 3 options, 4 options, like blood group. I have blood group A, blood group B, blood group AB, blood group O. Only 4 options. So it's called discrete variable or discrete data. So when I come to categorize them or group them, I have limited number of groups or categories. They cannot take any reading between A and B or B and O or AB and O. No, it has either to be one of them, must be one of these 4. Okay, so it cannot be something in between. That's why it's called discrete. So discrete here, like the sex of the person, male or female. Discrete, it is random variable also, but we can assume that we can assume only certain values. We cannot take any values. I have to take either blood group, for example, A, B, AB, or O. I cannot say, okay, I have blood group between them. I cannot draw a line and say this is A, this is B, this is AB, this is O, and draw a line between them. So what about the readings between this A and B? Is it AB? Between AB and O, is it ABO, or what is this group? There is no blood group. I cannot take any reading here. So such type of data, it cannot be represented as a continuous data, okay, by line graph. It has to be represented as bar chart or pie chart, okay, because I cannot have anything between them, between A and B. So it's called discrete data. So discrete data means the random variable, I can assume only certain values, okay, from a finite or countably infinite sets. Okay, so this is for the discrete variable or discrete data. So what about the continuous data? Continuous data, like the height of the person, I can draw a line and I can say, okay, 160, 108, 170, 180, and so on, 190, and I can draw a line. Okay, any value here, it could be the height of a person. It is possible. Okay, it could be, if the value is 190.1, it could be a height. If it is 185.3, it could be a height. If it is 167.15, it could be a height. So the height of the person can take any value. So it's called, the data is continuous. I can get a point on the x-axis and go up to reaching the graph and take the reading from the y-axis, and I have a value, and it is a realistic value. It could happen. Okay, so that's why called continuous data. I have continuous data. I can go continuously. It is not discrete data that I have only this one, A or B or AB or O only, four readings or four points only. So I have here continuous data. I can take any reading between them, but here it is discrete. I cannot take any reading between the four categories which I have. Okay, so continuous data is a random variable. It is an infinite number. It can take any number. As I told you, 167.15. It could be 167.149, 14932, whatever. It depends on the accuracy of the device which you are using. So it can be infinite. Okay, an infinite number of values, any possible value are possible. Okay, over one or several intervals. Okay, like the height of the person. It is infinite number of possible values. I cannot limit it. Whatever it comes, it depends on the accuracy of the device which we are using for measuring this quantity. We can have any infinite number, but for discrete number we have only limited or certain values. Okay, so the difference between them, the discrete data, it's a random variable, but it have only certain values. Okay, continuous, it is a random variable, but it is infinite number of values. Okay, this is the difference, the main difference between them. Here in this slide we have the outcome space. Okay, so I have done an experiment and I put the input, and the data is processed or measured or assessed, or the experiment happened or the survey happened. Then I got the outcomes. Okay, the outcome means the output or the outcomes. So what I need to describe this outcome data which I have, we call it outcome space, the available space for the outcome. Okay, what are the data available in this outcome space? Okay, the output space. So here we're talking about the outcome space. The outcome space contains all the possible outcomes, all the possible outputs. Okay, all the possible reading, all the possible measurement of an observation or an experiment. Okay, so the outcome space, this is the space which includes all the possible outcomes. Okay, all the possible outcomes, we are calling them together the outcome or the output. Okay, or the reading or the measurement or the observation space. Okay, so here we are calling it outcome space. So outcome space, the space contains all possible outcomes of an observation or an experiment. So what about the probability distribution? About the probability distribution of this outcome space, the probability distribution has two essential properties. Okay, of the distribution. First of all, the probability, like any probability, it cannot be more than 1. It should be less than or equal to 1, or greater than or equal to 0. So the minimum value for the probability of anything is 0. Okay, which is impossible. We call it impossible. So its probability is 0. And maximum will be 1, which is certain. If I have certain probability, it will be 1. So the probability between 0 and 1, and it could be equal 0 or equal 1. So it is more than or equals, okay, more than or equals 0, okay, or less than or equals 1. Okay, this is the second property. Okay, so the first property about the distribution, the first essential property of the probability distribution, that the probability can not be more than 1 or less than 0. It has to be greater than or equal to 0 or less than or equal to 1. Okay, the second probability here, that the sum of all possible probability for one criteria or for one experiment or observation, it has to be adds up to 1. The sum of them must be 1. Okay, so if I have the probability of the head and tail, for example, the probability of head and tail must be 1. If one of them 0.7, the other one should be 0.3. If one of them 0.5, the other one should be 0.5. The other one 0.2, so this should be 0.8, and so on. So always the total probability is adding up to 1. And they gave us here the example of the rolling affair dice. Okay, the outcomes, I have the outcomes of this experiment, that I might end up with the face of the dice, which is 1 or 2 or 3 or 4 or 5 or 6, any face of the dice. Okay, probability of each one of them is 1 over 6. So the sum of the probability, it must be equals to 1. If I get all the possible probability, I add the probability of the 6 faces. So 1 over 6 plus 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 1 over 6. All of them will add up to 6 over 6, which is 1. So all the probability must be 1, okay? And none of this probability can be more than 1 or less than 0, okay? So if I want to take the cumulative, for example, I get the first one. The first phase is 1. Okay, if I get the first phase 1, and this probability is 1, and second phase, let us assume that we get them one by one. First phase 1, second phase 2, third phase 3, and so on. Second phase, another we got 2, so the probability of the first one will be 1 over 6. Probability of the second one, another 1 over 6. So 1 over 6 plus 1 over 6, it will be 2 over 6. So this is called cumulative. I'm cumulating them, adding them up. Okay, so if I throw the dice 3 times and I got 3, so the probability of 3 will be 6 over 6 plus 2 over 6, I'll get 3 over 6. So always I add 1 over 6 plus this one. Okay, so I get 4 over 6. Then I add 1 over 6 plus 4 over 6, I get 5 over 6. Then I add 1 over 6 plus 5 over 6, equals 6 over 6. So this is a cumulative probability. Cumulative probability must be equals to 1, because this is the whole, everything, the full circle must be equal, the percentage of the full circle should be 1. The percentage of the everything in full should be 100%. The total probability of anything, if I consider all the possible probabilities, must be adds up to 1. So here we have learned that we have the outcome, the phase, 1, 2, 3, 4, 5, 6, okay, and the probability of each one, and the cumulative. Cumulative, I'm adding the previous probability, the total of the previous to the new one. So the probability which I have so far, the cumulative, 1 over 6, because I have got only 1 so far. The new one, I got 1 over 6, I add this one here, so it would be 2 over 6. Then I add the next one to the cumulative, it would be 3 over 6. The new one to the new cumulative, it will be 4 over 6. The new one to the new cumulative, and so on. Like if you have a pot and you fill it with something, okay, and then you come next and you fill another thing, okay, and then you came and fill it with the third color or third material, and fill it with another color. So this is called cumulative. So the level which I reached so far, it is not for this brown color. It is for everything from the beginning. It's cumulative. This plus this plus this, all the previous ones. Cumulative up to now. Okay, this is the concept of the cumulative. In this slide, we are going to discuss how to represent the random variable by the probability and the cumulative distribution function. Okay, so here representation of the random variable by probabilities and by cumulative distribution function. If we look at this table, like the dice example which I have taken, the dice, we have 6 faces. So it will be either one face, if we throw it once, it will be either the face which will appear will be 1 or 2 or 3 or 4 or 5 or 6. Likewise, I have here another experiment for an item which will show only from 1 to 10. Okay, like the dice from 1 to 6, this will show from 1 to 10. So from 0 to 10, sorry, from 0 to 10. So it will be either 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10. It will be any of them. So I threw it and I got 50 reading. Okay, so when I group them or categorize them, I find that the 0 appears 1 time. The frequency of 0 is 1 time. The frequency of 1, it appears 4 times. The frequency of 2 appears 6 times. 3, its frequency is 4, appears 4 times. The 4 appears 9 times, and so on. 8 appears 2 times. 10 appears 1 time, and so on. Okay, So this is called the frequency. Frequency, how many times it appears. So the total number of the outcomes which I have got, the appearance of the readings is 50. How I know that? Because the frequency here, 0 appears 1 time. Okay, 1 appears 4 times, 2 appears 6 times, 3 appears 4 times, and so on. So if I add all these readings up, okay, if I add all of them up, so I'll get here 50. So the total n equals 50. I have 50 readings, okay, and this is the distribution of them. So 0 appears 1 appears 4 times, 2 appears 6 times. So the total number is n. So the total number, don't confuse and get the number of faces. No, this is the number of faces. N number is the number of outcomes, number of readings. Okay, so I have the face which is called 3 appears 4 times. The face named or called 4 appears 9 times. So this is the number of outcomes, number of reading, 9, 4, 6, 4, 1, 10, and so on. So this is the n number, the number of outcomes which I have. So I have to get the number of outcomes, which is here in this example, he assumed that the frequency called k or f or k. Here I assumed it's k. So the sum of this k, if I summed up k, I'll get 50. Okay, so here n equals sum of k. Okay, equals 50. So n equals 50 in this example. Okay. So what is the probability relative frequency? Okay, we said that the relative frequency, how many times it appears to the total number. So the 0, for the 0 example of 0 appears 1 time out of 50. This is the total number. Okay, so it will be k, how many times the frequency divided the total. So 1 divided 50 equals 0.02. So I wrote here 0.02. The second one, 4, it appears 4 times. So it's a relative frequency. The relative frequency, just let me clear it. Okay, the relative frequency. So the second one appears 4 times. Okay, out of 50. So 4 divided 50 equals 0.08. So I wrote it here 0.08. This is called the relative frequency, and so on. I check 6 divided 50, 4 divided 50, 9 divided 50, 10 divided 50, and so on until I reach the last one. So the two properties or two criteria which we said that they must happen, one of them is the sum of all this relative frequency, the sum of this relative frequency must be added to 1. So the sum of the probability, EP, sum of probability, okay, sum of probability I equals to 1. So if I add up all these numbers together, I'll get 1. The total of them, you can try on the calculator, you will get 1. So in all the cases, the sum of the probability will be 1. So coming to the cumulative property, okay, or cumulative distribution. Cumulative means I arrange them, okay, phase 1, phase 2, phase 3, phase 4, 5, 6, 7, up to 10, okay, until I reach the last one, then I come to the probability. So I have here the probability of the first one, 0.2. I wrote it here because there is no items above it. So it will be, the first cumulative will be 0.2. The second one, 0.8. So I add 0.8 to the previous one, okay, to all the previous ones, okay. So 0.2 plus 0.8 equals 0.1, okay. So 0.1, 2, I have to add this one to this one to this one, okay. So it will be 0.12 plus 0.08 plus 0.2 equals 0.22, okay, 0.22. So in a simpler way, how I can do it without keep adding up all the numbers every time, adding up all the numbers again, how we can do it in a simpler way? Okay, so here in a simpler way, okay, what we can do, the first one will be written as it is. The second one will be the relative frequency plus this one, because this one's supposed to be the cumulative, the sum of the previous, okay? So I get 0.8 plus 0.2 equals 0.1 or 0.10, okay? Then the new one, 0.12 plus the cumulative, the last cumulative, because this cumulative is the sum of the previous. No need to count to sum them again up, okay? So 0.12 plus 0.1 equals 0.22. So the third one, any numbers. So this number 0.18 plus the previous one, the previous cumulative, so we'll have 0.48, okay? If I come to this one, 0.04 plus this number, I'll get this number. So in order to get any cumulative number, okay, I have to add the new reading to the previous cumulative, okay? The new reading plus previous cumulative, okay? The previous cumulative. So let us assume I don't have any of these numbers, okay, and I want to add them. So the first number we always write it as it is because there is no any number before it, okay? So if you put something here in the bowl, this is the first item, there is nothing before it, so it will be only the old quantity which you have, it will be this one. But then if you add a new color or a new item, so you will have two different colors, then so and so on. But the first one, you don't have anything except it only, okay? So the first one will be written as it is, the relative frequency, it will be the cumulative because nothing before it, okay? So coming to the second one will be the new readings. So I need the cumulative here, okay? The cumulative here will be the new reading 0.08 plus the previous cumulative 0.02, it will be 0.1, okay? So coming to the next one, I want to get here the cumulative here. So how can I get the cumulative here? It will be the new reading 0.12 plus the last cumulative. What I should do initially, I should add this one to this one to this one, all of them. But I already have these two added together here. So why I have to repeat again? So just I have the relative frequency, the new relative frequency plus 0.1. So 0.12 plus 0.10 equals 0.22, okay, which is this one. So what about the next one? The next one will be 0.08 plus 0.22. So this is the cumulative, last cumulative. I added the new one, so it will be 0.30. Okay, so the next one will be 0.18 plus 0.30, 0.48. Okay, and so on. So I hope this one is clear. So if I want to represent them, in order to represent the individual or the relative frequency of individuals, so what I have to do, I put on x-axis each category. First category 0, second category is 1, okay, category 2, category 3, 4, 5, 6, 7. So 1, I have only frequency 1, I put 1, okay, or probability, sorry, it is probability, it is not the frequency. If it is frequency, I have to take this number, the frequency 1, 4, 6, and 8, but here it is the relative probability, okay, or the relative frequency probability. So here it will be 0 will be x equals 0, it will be 0.02. I come here about 0.02, okay. Then for 1, 0.08, 1, 0.05, 6, 7, 8, approximately it's here, okay. So for 2, it is 0.12, okay, it's almost here, okay, this is the one. For 3, for example, it will be 0.08 again. For 3, it will be 0.08. See, this 1 is 0.08 and this 3 is 0.8. They should be at the same level. So 1 and 3, they are at the same level, okay, and so on. So this is how to plot or to represent the probability, the relative frequency probability, okay, the relative frequency probability for each individual item. So it will go up and down. It depends on the reading. So 1 is down here, up, down, up, down, down. It depends on the the frequency if I'm representing frequency, or the probability if I'm representing by the probability. So in our case, I'm using the probability X, so I have to use this column, the probability. So, but looking at the cumulative, if I come to look at the cumulative cannot go up and down. If you have a bowl and you put the first layer and then you put the second layer, let's use different second layer, okay, and then you get a third layer, okay, third layer, and then you get a fourth layer. So it will never be possible to come down. Every time you are adding more, so it cannot be down. You cannot go down. So that's why if you look here at the distribution of the cumulative, okay, cumulative distribution function, always it will go up. Here it is down at 0, it will be up, up, up. Always it goes up to the maximum. So this is the last level. You remember when we have this bowl example, okay? We have this one, the maximum which we reach. So here this is the maximum. So we keep adding up until we reach the maximum. It cannot go down. This is the property of the cumulative. So looking at this cumulative here, so for 0, we wrote the probability of the 0, which is 0.02. Okay, then the probability of 1, the cumulative probability. Okay, this is 1, the cumulative probability at 1, it will be 0.2 plus 0.8, okay, which equals this one. So 0.1. The probability of 2, it will be the sum of all the previous ones. 0.2 plus 0.2 plus 0.8 plus 0.12 equals 0.22. So here we'll put it as 0.22. Okay, and so on. Keep adding up. But because we have already calculated them here, no need to recalculate them again, because I have already 0.2, just put it here. 0.8, I just adding it to the previous cumulative to get the new cumulative. Okay, then the new cumulative, add the new reading to it, get the new cumulative. So the last cumulative here, add the new reading, get the new last cumulative, and so on. Keep adding here and get this line, the cumulative, because this one is the sum of the previous. If you look at the formula here, you will find F2, okay, F2, so let us clear this one. F2, okay, here, the cumulative at 2, it will be equal that the probability of x equals 0 plus the probability of x equals 1 plus the probability of x equals 2. So probability of 0 plus probability of 1 plus probability of 2, all of them. But in the table here, no need every time to add this plus this plus this, this plus this plus this plus this, and so on, because we have already the new cumulative. This cumulative here, cumulative at any point, this cumulative, for example, equals all the probabilities above it. Okay, so equals the sum of all this. Okay, because the probability here equals what? Equals this plus this. Probability here equals all of them, and so on. So no need to repeat. I hope this one is clear. Okay, it is simple, but I hope it's clear. Okay, so until we come to the total probability, since this graph is not the frequency can reach up to 50, 60, 100, but here this is the probability. The cumulative probability must be adding to 1. Okay, this is cumulative. So when I reach the last one, it must be 1. The last cumulative must be 1. Okay, so here I go up until the last reading 10, it must be 1. Okay, so this is the full probability. I hope this one is clear.